Okay, good day. So today we will be discussing the fundamentals of material balance. Okay, so this is the chapter 2 of the book by Towler and Sinnott, Chemical Engineering Design. Okay, fundamentals of material balances. So, what are objectives in this lecture? Well, first of all, we would like to understand how to do a mass balance for a process flow. Okay, so in an industrial plant, okay, so there are many processes. There are some that uses chemical reactions, like mga planta sa uh, Coca-Cola, for example, or beverages, cement production. So those processes involves chemical reaction. So the question is, how do we analyze or get the material balance for a specific process? Okay, now what is the importance of getting the mass balance? Well, one of the uses of it is you will be able to size your equipment. No, the size of the equipment that you will be using for a production processes will be dependent on the amount of flow rate that will be passing onto the system. Okay, so uh, we'll use the conservation of mass. Well, basically, kaning equation is very simple. No, you have the material out is equal to the material in plus generation minus consumption minus accumulation. Now, for the steady state process, there will be no accumulation. Okay, because the parameters in the system does not change for a steady state process. As well as, if there is no chemical reaction, so what will happen to this equation? May mo na siyang material in is equal to material out, or mass in is just equal to mass out. Okay, so now there are many processes that do not involve chemical reaction. For example, sa mga limestone preparation plant, wherein you want to reduce the particle size of your limestone so that you can use it for a certain process. Now, in that plant, wala kay chemical reaction, no? You just use some crushers, rollers, what else? Conveyors. So, in analyzing the mass balance for that process, you just use this formula: material out is equal to material in. Okay, so you have examples here wherein you're given a composition. Now you have a 2,000 kilogram of 5% slurry of calcium hydroxide in water. Calcium hydroxide. So this is the chemical formula of calcium hydroxide. 2,000 kilogram of 5% slurry is to be prepared by diluting at 20% slurry. Calculate the quantities required. The percentages are by weight. Okay? So, unsay mong buhaton eh. Now, ganing mga percentage or the composition niya, pasabot ra ni is that 5% slurry, meaning by weight man siya. So 5% sa total weight of the solution is calcium hydroxide. Okay, so this is the problem. You have you want to mix a 5% calcium hydroxide now with the total mass of this solution is 2,000 kilograms. Okay, 2,000 kilograms. And then you want to prepare it with mixing 20% calcium hydroxide plus water. Okay, so the question is how much should these components be? Okay, so pila daw. So we will assume, okay, so we will let x this one 20% ng calcium hydroxide. Okay, dili man given sa problem. Plus mass po sa water is y. So the first equation that you will get from this problem is 2,000 kilogram must be the total mass by adding x plus y. Okay, so that's it. And then by virtue of conservation of mass, ang kaning 20% nga calcium hydroxide, ang amount of calcium hydroxide dire, pag add ni mo water, wala na siya na change. But rather, neutral lang ang amount of solvent, which is water. Neutral lang siya, nadugangan lang mo nang migamay ang concentration dire. Therefore, the mass of CaOH2 from ganing 5% na slurry, makuha na nimo by multiplying it with the total solution 2,000. Okay, this is 100 kilograms. Therefore 100 kilograms di ay ang amount of calcium hydroxide. Okay, but since ang atong gipangita kay kaning x and y man pila ang value daw ani, we will use it. Okay, there is amount 20%. So by the virtue of conservation of mass, kining 100 kilograms is just equal to 0.2 times x. Therefore, based on this one, x is just 500 kilograms. So sa implication ni kanina ay nga 20% 20% composition of calcium hydroxide, 500 kg na yung masa ni. So based on ni makuha ni mo ang y, which is y is just y is just 2,000 minus 500, which is equal to 1,500 kilograms. Okay, so you now have get the components, no? Sabot ani, in order to prepare a 2,000 kilogram of 5% na calcium hydroxide, you need to add a 500 kilogram of 20% solution calcium hydroxide plus 1,500 kilogram water. Okay, now we will proceed with some examples on how to change from weight composition but into a molar composition. This is just a review of your chemistry class, and based on this one, this is the abbreviation of by weight basis. Okay, so you have this one, you have the symbol W over W or this one. Okay, so we have a problem, and we have an example wherein you need to convert a hydrochloric acid with a chemical composition of 28% by mass basis or weight basis, and express this one as a mole fraction. Okay, mole fraction meaning you need to get the number of moles of this, the solvent and the solute, and then you divide it one by the total number of moles. Okay, so we need to convert this 28% hydrochloric acid. So again, the basis for that is you assume a 100 kilogram solution. So the mass of hydrochloric acid for a 100 kilogram solution would be 28 kilograms, and for water would be 72 kilograms. And then you divide that one by the molecular weight. For water, this is 18. Ang unit ani is kilogram per kilomole. For hydrochloric acid, 36.5 kilogram per kilomole. So that is why when you divide the mass of hydrochloric acid with the molecular weight, you will get 0.77. The unit is kilomoles. And for water, divide 72 by 18, you have 4 kilomoles. So adding this one, you will get the total number of moles, which is 4.77. And then you divide 0.77 by 4.77, you get 0.16 and 0.84. So this is now the mole fraction. So there are times when kung mag-divide ka og composition sa isa ka sample, isa ka gas, gamay na kay number makuha. So that is why dili na advisable ang percent, no? So there are times you need to use the parts per million. So ang parts per million, instead na 100 multiply you multiply it by 1 million, 10 to the 6. Okay? So 1 ppm is 10 to the negative 4%. Kung gagmay na dyan kayo, you have parts per billion. Okay, let's proceed with stoichiometry. So stoichiometry is chemical. For a chemical reaction, you need to get the number of molecules of the reactants and products. Okay, and balance the equation. So ang objective ni mo is to balance this equation, ang yung reactants and products. So say for example, you need to manufacture a vinyl chloride from ethylene, chlorine, and oxygen. So this is the ethylene C2H4 plus chlorine plus oxygen. So ang product niya would be vinyl chloride C2H3Cl plus water. Again, you can do trial and error, but kung gusto kang dili ka ganahan mag trial and error, you can use this one, no? You let A ang number of moles sa reactants nimo for ethylene, and B for chlorine, C for oxygen, D for the vinyl chloride, and E for the water. And then you balance this for carbon. Ang carbon nimo sa imong reactants nga side is 2A. This is equal to sa imong product nga side 2D. So that is why A is equal to D. For hydrogen, for A is equal to 3D plus 2A, but since A is equal to D, munang substitute dire, we'll get that E is equal to A over 2. For chlorine, 2B is equal to D. Therefore, ang D nimo is just equal to A. So, B is equal to A over 2. And oxygen, 2C is equal to A, to E, rather. So, therefore, C is just A over 4. Now, you let A equal to 1, the equation becomes C2H4 plus 1 half Cl2 plus 1/4 oxygen is equal to C2H3Cl plus 1 half H2O. So to get rid of the fraction, multiply this one by the largest denominator, which is 4. You'll get this equation. Now, ano siyang equation? Balance na siya. Again, this is just a review. Now, we will proceed on how to analyze or get the mass flow rate of for a certain process. Okay, so this is our example, no? So kaning process is you for producing a polymer. Okay, polymer. So ang sequence niya is you have a monomer and then water and catalyst, no? So mo nang imong mga input nimo in order to make a polymer. Now, yun dire specify dire 10,000 kg per hour ang buhaton, no? Ang buhaton nimo. So, the question now is pila ang dapat nimo nga i-feed na monomer, water and catalyst. So kani siya lang tulo plus ang kaning recycle na kay recycle ng monomer no gikan diri ng mga wala nag-react mong recycle balik. Okay, and then imo nang i-feed sa imong reactor. It will undergo process, chemical reaction. And then you have this short stop agent. And then diri na din sa imong filter. No, magi sa filter, then dryer. And then you will now produce a polymer. So mao ni ang mga specification, no? Specification is sa imong equipment. Reactor selectivity for polymer is 100%. Slurry polymerization 20% by weight, monomer and water. So mo ni siya mag-determine sa imong reaction sa imong reactor pila ang amount of water and monomer nga imong i-feed diri. Conversion 90% per pass. So ang 90% per pass is sa imo aning sa dryer, sa imong reactor. 90% per pass. So pasabotan pag sulod sa monomer diri, dili man na tanan mahimong polymer. So 90% lang daw ang mahimong polymer. Ang the rest ato mo na tong unreacted nga imong ibutang diri sa recovery column. And then catalyst, ang catalyst niya is 1 kg per 1,000 kg monomer. So ang catalyst is to speed up the reaction, no? So mo nang mag-add ka ni catalyst. Then ang amount lang pud nga i-add nimo must be 1 kg for every 1,000 kg monomer. Short stopping agent 0.5 kg per 1,000 kg unreacted monomer. Filter wash approximately 1 kg per 1 kg polymer. Okay. Recovery column yield 98%. And then dryer feed 5% water. Okay? So morning specs sa imong product no giyon niya diri. Ang imong product daw nag-contain og 5% water and polymer loss in filter and dryer is 1%. So ang loss daw diri. Okay. So, unsa ang mga parameters nga atong kinahanglan pangitaw na ni? We need to get the mass flow rate sa monomer, water, catalyst, shirt stopping agent, feed water diri, and recycle monomer. Okay? So, pangitaw na to ning mga mass flow rate ani niya. So, mo ni ang objective sa material balance, no, to be able to determine the mass flow rate of every material nga nag-flow sa imong process. Okay, so asa man ta mag-start ani? You can start with the diri. So product kay gingon man diri no nga 10,000 kilogram per hour. So we need to produce 10,000 kilogram per hour. So the question is, pila ang atong monomer nga i-feed sa reactor? Pila ang water nga i-feed sa reactor? Pila ang catalyst para makaproduce og 10,000 kilograms? Okay? So, based on this one, diri ta mag-start sa imo ang kani nga system, filter and dryer system. Okay, kani filter. And then, ang basis sa atong calculation is 1 hour. 1 hour, no? So, again, more on, kung ano siya, more on chemical engineering siya nga aspects. But, actually, ang sa planta, ang mga mechanical engineer, pwede mo tamo apply good as process engineer. And as process engineer, or production engineer, mo deal in ta with ninani nga mga aspects, no? Ano man kay more on process man ta. So sa mga planta nag-involve man nag mga chemical reaction. Okay, so starting with this one sa product nimo, sa product side. Ngayon sa product, ang product nimo is na daw loss na 1%, no? Tama na makita ka ni. Polymer loss in filter and dryer is 1%. So, pag sulod sa polymer dire, na ay mawala daw nga 1% nga polymer. So, therefore, kung 10,000 na ang imong i-feed dire, 10,000 ang output, dapat taas-taas imong i-feed dire para makaabot kag 10,000. So, imo ra na siyang i-divide 10,000 divide 0.99. So, ang i-feed day nimo is ang i-input nimo dire is 10,101 kilograms. So, ang kaning 101 kilogram mo ni ang nawala. Okay? After that one, so nakuha na nimo ni ang value dire. Ang reactor na pud atong i-analyze. So, sa reactor side, so these are the components that passes to the reactor. So you have water, you have the monomer, you have the catalyst, and then you have the recycled monomer. You have also the shirt stopping agent. So at 90% conversion per pass. Okay, so we all know that 10,101 diri na siya. Ang input nimo sa filter dryer system 10,101. So for 10,101 and then 90% lang ang conversion pass. So ang monomer feed nga atong i-input diri di ay is 10,101 over 0.9 is 11,223. No? So makita na to nga dili tanang monomer mahimong polymer. So that is why kinahanglan nimo tas-an imong input para makaabot ka og 10,101. So therefore, the unreacted monomer, ang mga monomer nga wala na yung polymer is just 11,223 minus 10,101, which is 1,122 kilograms. Kung sa gamit ani niya, based on this one, makuha ni mo ang short stopping mass flow. Kay ang giyon diri short stopping agent, kinahanglan ka magbutang og 0.5 for every 1,000 unreacted monomer. So, mura ning 8 multiply of 0.5, you will get 0.6 kg dahil ang kani short stop agent. And then for the catalyst, imo na ni kani nga value kay ang giyon man diri nga ang catalyst nimo should be 1 kg for every 1,000 kg monomer. Multiply ra nimo ni og, or rather divide by 1,000. Ang catalyst nimo would be 11 kilograms nga ibutang sa reactor. And then so nakuha na nato ang monomer feed, kani monomer feed, short stopping, catalyst, so diretso sa water. Now ang water nga gi-feed nimo sa reactor is makuha dire nimo makuha slurry polymerization 20% monomer per water. So nakuha na nimo ang monomer, so ito lang ning ngayon yan 20%. So 20% daw ang monomer. So mo aning 0.2 is equal to, kaysa imong reactor mo man yung composition 20%. So 20% solute over the total solution. So 11,223 monomer divided by total solution, which is the water plus the monomer. Makuha nimo ang water will be 44,892 kilograms. Okay? So, based on this one, makuha na nimo dayon po dang usa ka dako imong pump nga gamiton or pila ka book pump, no? Kaya naman kay quantity nga kinahanglan abton or na calculate. And then balik ta sa filter dryer sa subsystem. Water in polymer to dryer is at 5%. Okay? So naay so ang 10,101 times 0.05 divided by 0.95. Okay? So ang water content sa imong product is 532 kilograms. Okay? 532 kilograms. So tan-awa na to dire. Okay, so naman kay water dire sa reactor. Unya ang product nimo na water nga 532 kilograms. Naman po kay wash water. So pila man ning wash water. Ang wash water nimo makuha na nimo dire. Filter wash water is 1 kg per 1 kg polymer. So kung pila tong polymer kani 10,101 muna dahil ni, no? Balance over reactor filter dryer subsystem gives flows to recovery column. Kaysa imong recovery column ang good. Recovery column, no? Diba nagbutang kag water diri 44,000. Filter man na nimo. And then pag-abot diri kay 532 na lang man ang amount of water from 44,000. So ang uban. So ang the rest of water diri na sa column mga sulod. Yan napa kay wash water. So kani siya water o unreacted monomer ang sulod. Okay, so mo na water and monomer nga unreacted. So ang total water nga mosulod sa column is 44,892 plus 10,101 mo ni ang wash water minus 532. Okay? So mo na ang mosulod dire. And then with 98% recovery, so ang ma-recover daw is 98%, so 1,100 kg ang monomer nga ma-recover. So mo ni dire. Mo ni dire. Mo ning recycle monomer. So mo na dahil ni, no? Composition of effluent is 23 kg monomer, 54,461 kg water. So ang fresh monomer required nimo would be, diba, kay kuan man ni daan dere, pila gali ning reactor feed. Ang reactor feed nimo is kani 11,223. So 11,223 minus 11, naka-less ka og 11 na, so ang i-feed na lang nimo 10,123 kg. So mo na ni siya ang material balance, no, example. So kung atong i-summarize, na akay target nga production dere, the question is how much is the monomer, water, catalyst, skirt stopping agent, wash water, recycle monomer nga imong gamiton para ma-achieve ang 10,000 kg polymer production process. So that's just the basic, no? So napay mga lahi pod na types of plant, lahi pod ang way of pag-solve, but basically inani ra gyapon, no? For a kanang no chemical reaction na process, like katong giyon ako nga limestone plant operation, or ano to siya, like kanang mga nag-involve of crushing, grinding, basic ra na siya nga addition, no? Basic ra siya nga addition. So that's it, no? Hopefully just review this problem in order to get the idea of how to conduct a material balance.